On to question 5. Question 5 was overall testing your knowledge of scatter plots and regression analysis, both in determining and analyzing scatter plots in general, regression lines, and also the significance tests related to that. So it ended with a hypothesis test of linear regression. So we're starting with part A, where you are describing the relationship between the circumference and weight in the context of the problem. So that means you should include those two variables in your response, and you should include the 3 things they're looking for: strength, direction, and form. So a strong, positive, linear association between my 2 variables. So that's your part A: strength, direction, and form. In part B, they gave you an equation of the regression line and gave you a value and worked you toward calculating the residual. And they broke it down into multiple parts. So they gave you the observed, right? This is my observed. And specifically, this would be my observed Y value. And then to get the predicted, you plug it into the regression line, which is what they're asking you to do in this first part. So to get the predicted, plug in the 145.9 because the circumference is the x coordinate. So that goes in for the circumference, 145.9, and see what you get out. This is my predicted value from the least squares regression line. So then to get the residual, we take observed minus predicted. So my observed was told to us, the predicted I just calculated, and that gives me the residual. Then over in part C, we are inching towards the linear regression test by talking about the slope. So interpret the slope in the context of the problem. For every additional centimeter of chest circumference, in other words, every time x goes up by 1, y is predicted to go up. And it's going up because the slope is positive. Make sure we have that word predicted on average, approximately like those kind of words in our interpretation of slope. Part D. We're doing a hypothesis test of whether the slope of this regression line is different from the slope of the sandbars. So that test statistic was calculated to be 3.408, and they wanted the p-value. So in order to get the p-value, that is a t-score, because this is a t-test. That is a t-score. And remember that in these t-tests, the degrees of freedom should be n minus 2. So our degrees of freedom in this situation would be 30 minus 2, which is 28. And because the alternative was that beta was not equal to 4.5, that means it was a 2-sided test. So when you calculate out the t-score, get that probability that it's greater than the 3.408, you need to take that probability that you get and double it so that both tails are included in the probability that you calculate. So 0.002 is the p-value. And then it asked you to make an interpretation of whatever p-value you came up with. So whatever p-value you came up with, compare it to the alpha level, decision about reject or fail to reject. In this case, we reject. There is enough evidence for the alternative, which is that the slope is not the 4.5, so that it's different from the slope of the sandbars. So it follows a different pattern in the regression line. That's what the hypothesis test leads us to that conclusion of. We're seeing if we can use that slope of the different distribution. And turns out, reject the null hypothesis, it would not be wise to use it. Then, finally, for question 6. Question 6, as always, compiles together many different ideas. This one was centered on a normal distribution and doing some analysis as to whether the normal distribution is looking like it was expected to. So it used ideas of describing shape and center and using probabilities to make interpretations about what is reasonable to conclude, all of those different ideas. So necklace is randomly selected. So we're just selecting one necklace, so it's a straightforward normal distribution calculation. If you calculated the z-scores, these were the z-scores, 0.8, negative 0.8. It was the same distance away from the mean above and below. So it should make sense that it's the same, one's positive, one's negative. If you did normal CDF, that's your normal CDF. But remember, you needed to show that normal distribution with the mean of 300 and the standard deviation of 5. That is the distribution that you were using in the calculator. Then it gave you a new distribution and said, hey, what if we took samples of 2? Random sample of 2 and calculates the sample mean. So now we're looking at a sampling distribution of all samples taken from this population. Now normally n being 2 would be trouble for whether we could use a normal distribution, but in this case the population distribution was normal, so we can keep carrying on using normal distributions. So probability that the sample mean will be greater than 303. Since n is 2, the mean is still the mean. The standard deviation is standard deviation over square root of n. So that 5 over square root of 2, and that's my new standard deviation. But then the rest of the process works very similarly, where we calculate the z-score, we work and get the probability that we're higher than that z-score because it's greater than 303. And that gives us a probability of 0.1981. So then, do we have enough evidence to say that it deviated far enough that we would say that the machine is not working properly? Well, not enough evidence. And there's not enough evidence because that probability is likely enough to have potentially just happened by chance. Just by chance of sampling variability, we happen to get a mean this high, and that's not any indication that we're in danger of thinking the machine is not working properly. Then it said, let's talk about the range. Capturing the range, and had all these different graphs of ranges that we're about to compare. But first, they asked you to just compare the standard deviation of 5. So just talk about and describe the distribution in graph 1. Then it talks about what happens in graphs 2 and 3 as standard deviation goes up. So some of the things that I said about graph 1 is that it was skewed to the right. So I talked about the shape and calculated around where the median would be, which would be at the 50th percentile. So when we compiled up to 0.5, and the median was around 5, very few of those distributions had a range that was greater than 20. And so was referring to, if you look at this graph, greater than 20 would be almost none of them. Very, very small slivers. And that's one of the main things that changes. For example, look at the amount that are greater than 20 here, and the amount that are greater than 20 over here. In fact, they had to change the scale a little bit because there were so many more values that were on that high end. So that was another thing you could say, in addition to talking about the fact that the shape remains skewed right, but then the values spread out more, the variability increases, and the median starts to get larger. where that 50th percentile is shifts and shifts further to the right. So greater median range as n increases. Now, going back to that standard deviation of 5, this first graph, what they asked is, let's say we got a standard deviation of 10. Well, let's think about the chances that the standard deviation is that high, which I calculated, I compiled up and added up some of those areas. This is an approximation. But saying, is a sample range of 10 unusual? I compiled up a bunch of them that were, and decided that about 19% of them had that range or larger. So that does not give convincing enough evidence that the machine is not working properly. So the idea in the final part of this question is that you made a determination in part B based on the probability that you got in part B, this probability up here, the 0.1981, and you calculated a proportion and how unusual the 10 was. And based on that, making a conclusion about whether those two put together give us reason to doubt that the machine is working properly. And we're saying, well, the mean was not some extremely unusual value, and the range was not an extremely unusual value. So there isn't enough evidence for us to go to the conclusion that the machine is not working properly, and we may just say that it's due to sampling variability. So that's the compiling of the idea of that question. Where it was going with this is taking together different features of the distribution. Is there reason to suspect that something is off with what we expect the results to be? And it kind of walked you through, okay, what would we expect the results to be? What are we getting out of this? And how does that affect what we think about whether the machine is working properly? These are the values we expect to get. These are the values we got. Are they far enough apart that we would have doubts over whether things are working properly? And in this case, we say no. It's not far enough away from what we would expect to say that it's not working properly. And that's your rundown of all the questions. Thanks for watching.